Today we are going to view a hands-on presentation that covers the process of driving a test pile. The MnDOT Office of Bridges and Structures developed this video as a training aid for construction inspectors. As part of the presentation, we will cover the collection of the data for the test pile report by reviewing the contract documents. You will follow along and fill in the appropriate blanks on your test pile report. As the work progresses, complete the form as if you were a field inspector on this project. We will take you through a review of the bridge plan, the standard specification for construction book, the special provisions, pile buck hammer specifications, and finally, the MnDOT Bridge Construction Manual. This will be followed by the preparatory work in the field, such as the review of the hammer, piling, and staked location of the piles. During the actual pile driving operation, you'll need to count and record blows per foot. We will then pause and allow time to convert the blows per foot into penetration per blow and calculate the bearings. You'll need to have a blank test pile report, a calculator, 2000 standard specifications for construction book, and piling weight sheets from the MnDOT Bridge Construction Manual. Now you'll want to have your test pile report in front of you and be ready to collect data for the project description section in the upper right corner. This is a replacement project in the widening of Interstate 94 for additional lanes of traffic. A temporary bridge was built as a bypass and has now been removed to allow for this construction. Bridge 27 V39 is located on Interstate 94 over County State Aid Highway 8, also known as West Broadway Avenue. The state project number is 2786-27V39, and the bridge is located in Hennepin County, 1.5 miles west of U.S. Highway 169, therefore making this the Metro District. Today we will be driving a test pile in the west abutment. Looking at sheet 2R in the plan, we locate the schedule of quantities for the entire bridge. We see there are two lengths of test piles for this bridge. There are 70-foot test piles and 60-foot test piles. We can also see the unit of payment is by each for these test piles. Also note the foundation piling and the unit of payment, which are linear feet. The quantities shown on foundation piling are estimated lengths only, and the final quantity delivered will be based on the information gained in driving the test pile. Going back to the title sheet's general elevation view, on sheet 1, we can see the substructures consist of only the west and east abutments. Our focus will be on the west abutment, so let's pan over to the list of sheets and locate the west abutment details. We see here that they are on sheets 6 through 12. Turning to sheet 6, we find the footing plan. Now turn your test pile form over to the back side and roughly sketch the L-shaped footing in the drawing area provided. Now locate test pile number 3 on the plan sheet and sketch its location in the footing on the form. Remember to always include the north arrow. Turning your test pile report back over to the front side, you will see that the pile load bearing information will be located here at the bottom of the page. The abutment design load is 57.9 tons per pile. Enter this design load information in the space provided on the test pile report. Remember, this is the minimum bearing acceptable. In the right corner of the sheet, we see that the pile notes indicate the test pile lengths are 70 feet and the foundation pile lengths are 60 feet. Generally, test pile lengths are 10 feet longer than the expected penetration. Now we will go back to the footing plan. We note the pile spacing layout and how it is tied to the working point E. This is important as you'll be checking the layout after the contractor has staked the piling location. Always locate your test pile location from a working point. Next, we will need to look in a couple of places for the piling cutoff elevation. Turning to sheet 7, we find the bottom of footing elevation to be 887.38. We also know the piling extends up into the footing, but how much? Turning to sheet 11 and looking at section AA, we see the projection to be 1 foot into the footing. You'll need to add 1 foot to the bottom of footing elevation, which we just saw. On the front sheet of your test pile report, under the Pile Data section, enter 888.38 on the cutoff elevation line. Now that we know the cutoff elevation, we need to familiarize ourselves with the borings so we can estimate a depth below cutoff where the pile might encounter some substantial resistance. Looking at the index, we see that the borings are located on a sheet between 36 and 43 of the plan. Turning to sheet 39, we locate some information indicating where the soil boring holes are located and also indicate the test pile locations. As you can see, test pile number 3 is located at the south end of the west abutment, near boring number B4. Turning to the boring elevations on sheet 40, we see an elevation view of B4, indicating the type of soils encountered in the test hole. Alongside the boring hole are numbers indicating the density of the soil. For your information, the numbers represent the blows per foot using a 140-pound weight dropped from 30 inches. As the density of the soil increases, the number increases. As we take a closer look, we see at elevation 855, or about 35 feet below cutoff, a dense layer of sand that will provide some hard driving. One of the last items we should look at is standard detail B201, located in the standard details sheets. Looking on sheet 1, in the list of sheets, we see that the details are located starting on sheet 29. This detail shows the contractor how to splice a CIP pile. It also provides data on the type of acceptable electrodes, temperature ranges for doing the welding, and general construction details. Handling and storage of the electrodes is also important. Now let's go back to the front side of your test pile report, where we will fill out the pile hammer data section. In the pre-construction meeting, the contractor told us that he would be using the Delmag D25-32. Knowing this, we will need to get some data on the hammer for computing the bearing. We have chosen to get data from the Pile Buck Pile Hammer Specifications pamphlet. Looking across the line, we see that the D25-32 is a single-acting power-driven hammer. The weight of the ram or piston is 5,513 pounds, and the maximum rated energy is 58,250 foot-pounds. Soon after receiving the hammer information from the contractor, we qualified it as per the spec book. Our goal was to determine if it would meet the requirements and would be able to drive 160% of the design bearing required. Our final piece of information, now that we have the pile hammer data, will be to review the 2000 Standard Specification for Construction book, as noted in the construction notes on sheet 1. The piling information in the spec book is under Chapter 2452. This chapter will show us the correct formula for the type of pile we are driving. Find the formula for shell type piling driven with power-driven hammers. We will wait until you have recorded the formula on the bottom of the test pile report in the space labeled Formula Used. Now that we have our formula, we will need to gather information to use in the formula. The first variable is the energy used during driving. As we see in the video, the piston is only visible from the back side of the hammer. So we will estimate the drop to be about 6 feet. If the piston cannot be seen, the spec book allows for a 25% energy reduction of the manufacturer's maximum rated energy. The MnDOT Bridge Office recommends that method be used as a last resort, as the most representative data is to observe and record the fall of the piston or ram. We also want to look up the minimum wall thickness for the piling. Opening the spec book to Chapter 2452, we will find that the material specification number for steel pile shells is 3371. Turning to Table 3371-1, we find that our 12-inch CIP piling should have a minimum wall thickness of 1/4 inch. The final part of our review will be of the special provisions. Looking at the index for the SB, which stands for Special Provisions Bridge, we will now review the piling section on page 25 SB. SB-15.1 is about commercial dry fit splices not being used within 10 feet of the pile cutoff. SB-15.2, payment for pile splicing, is clarifying that the test pile length shown in the plan is full length. If the contractor furnishes the test pile in 2 pieces, there will be no payment for the splice. In other words, if the contractor starts with a 40-foot piece and then makes a field splice adding a 20-foot section to complete the driving, he would not qualify for a splice payment. In the MnDOT Bridge Construction Manual, you want to familiarize yourself with Section 150, Pile Driving. We will be using the charts and tables in this manual as we complete the test pile report form. Now let's complete the pile data section on the front of your test pile report. We will be driving test pile number 3 using 12-inch diameter CIP. The contractor has told you he will be driving a full 60-foot length of pile. You'll need to refer to figure F 5-393.164, Pipe Piles, Dimensions and Properties, for the weight per foot to calculate the weight of pile. Calculate the weight of pile and enter it on your report. You also need the weight of the cap. The contractor has furnished the weight, which is 2,680 pounds. Record this on the weight of cap line. Let's review all the entries completed to this point. Here the inspector is measuring the travel of the ram in the hammer sleeve. As the inspector checks the hammer, he finds it's the Del Mag model D25-32 single-acting power-driven hammer. The base of the pile leads is to the right in the picture. Here the contractor's men are assembling and tightening up the leads. Inspecting the pile shoe welds. Inspecting the pile shells for straightness and any damage. Checking the heat numbers against the certifications furnished by the contractor. Now you will experience a typical setup procedure prior to driving a test pile. Following the setup, you will see the driving of test pile number 3. Marking out the pile locations in the field. This is the contractor's responsibility, with the inspector checking the layout. The inspector marks out the test pile every foot and delineates every 2 feet for ease of locating the depth below cutoff and recording driving operations. Lifting the leads. Be careful where you're standing. Lifting the test pile and placing it into the leads. Raising the pile hammer and placing it on the pile. Note that the pile cap is cabled to the hammer, but free to sit on the pile. Align the piling and check to make sure it is vertical. Starting the hammer. Note that the test pile markings started at 20 feet. Start your markings at 5 feet and collect blows per foot as early as possible, as it is hard to collect accurate data when the hammer is first started. Now you will see the setup of test pile number 3. Now you will see the driving of test pile number 3. The hammer starts driving in earnest. For purposes of this video, you will wait until the pile gets to approximately 35 feet below cutoff before you begin counting blows per foot and recording your numbers on the test pile report. We will furnish the actual counts at the end of the driving. Soon you will see a highlight line appear on the screen. This is the cutoff line for this pile. Use this reference line to count your blows per foot. You will start counting when the 35-foot mark gets to this reference line. Start counting blows for 35 feet below cutoff now. the final series of 10 blows. The driving is complete with a final measurement of 1 3/8 in 10 blows. The inspector uses a mirror to check for damage and a rock to indicate no water. Let's take a look at the filling in of the test report. Here you see the columns for blows per foot and penetration per blow being filled in. This is the data that you recorded during driving. Use the conversion chart from the MnDOT Bridge Construction Manual to calculate the penetration per blow for all your entries. For example, just to the right of blows per foot is the penetration per blow. Looking at 24 blows per foot, you'll note that the penetration per blow is a 1/2 inch. The calculation is simply 12 inches divided by 24 blows per foot, which is equivalent to a 1/2 inch of penetration per blow. Go ahead and calculate your penetrations. Your sheet should look similar to this when it is completed. Now that you have completed the step of computing the penetration per blow, you can calculate the bearing for all of your entries. This sheet shows the calculation for the last 10 blows. At the end of driving test pile 3, the contractor marked off a series of 10 blows, and the inspector then measured the distance. Follow along as I walk you through the calculation. The last 10 blows equaled 1 3/8 inches. To convert the 3/8 of an inch into decimals of a foot, you divide the two to get 0.375. Adding the 1 inch to that, you get 1.375. So your last 10 blows gave you 1.375 inches. Take the 1.375 and divide it by 10 blows to get inches of penetration per blow. Therefore, the final penetration is 0.138 inches per blow. Looking back to the test pile report, we see the formula we will be using for this cast-in-place pile. Follow along as I walk you through calculating the bearing for the 25 feet below cutoff line. Let's break the formula down. Take 3.5 times E, which is 33,078 foot-pounds. Take S, which is 0.632, plus a constant of 0.2. Take the weight of the ram and add it to the sum of the pile plus the cap, times a constant of 0.1. Take the weight of the ram and add it to the pile weight plus the cap weight. Doing the math, you get 82,377 pounds. But to get tons, you will need to divide the total by 2,000, the number of pounds in a ton. 41 tons is your answer. The next calculation sheet is for the final bearing of test pile number 3. Doing the math and then dividing by 2,000 gives a final bearing for the 0.138 inches per blow of 101 tons. Go ahead and calculate all of your bearings. And when you're done, check them against this final sheet. It is important that you record the driving time for future reference. When the calculations are completed and checked, you will call the data into the MnDOT Bridge Construction Office for foundation pile length authorization. Be sure to review the special provisions prior to the start of the pile driving for possible minimum pile penetration or maximum pile length.